Hello, good day viewers. In this tutorial, we are going to solve some word problem questions related to trigonometric ratios. So if you are new here, consider subscribing. Press the bell icon so that you will be notified whenever I upload any content. And don't forget to share to your learning colleagues. Alright, the first question here reads, a 4-meter long ladder is placed against a wall. The angle between the ladder and the ground is 75 degrees. How far off the wall does the ladder reach? Okay, let us make a sketch here. Suppose this is a wall and this is the ground level, and we have a ladder right here. You should know that this angle is right angle, right? So how far up the wall does the ladder reach? So we are talking about this vertical distance. Let's call it x. So the ladder itself is 4 meter long, so this is 4, right? And the angle between the ground and the ladder is 75 degrees, so this angle here is 75 degrees. So we asked to find this one. So what is the relationship between this side and the hypotenuse? You can see that the missing side is directly opposite to the acute angle, so we say that it is called the opposite side. The opposite and hypotenuse is related with sine. So sine of 70 degrees, 75 degrees is equal to opposite divided by the hypotenuse. All right, you multiply by side by 4, we have 4 multiplied by sine of 75 degrees. Use your calculator, press everything. And to 2 decimal places, this is 3.86 meter. Now let us move on to question number 2. A 5-meter long ladder is placed against a wall. It reaches 4.3 meters up the wall. What is the angle between the ladder and the ground? So we have the wall here, we have the ground here, and we have the ladder right here. So this time around, this vertical distance is given as 4.3 meters, and the ladder is 5 meters. Then this angle is unknown between the ladder and the ground level. Let us call it theta. So we are looking for this. This is opposite, this is hypotenuse. We have sine. So therefore, sine of theta is equal to opposite divided by the hypotenuse. Therefore, theta will be equal to sine inverse of 4.3 divided by 5. Just plug everything into your calculator. And this is approximately 59.32 degrees. Theta is equal to 59.32 degrees. Let us move on to question number 3. A ladder is placed against a wall. The base of the ladder is 4 feet away from the wall. The angle between the ladder and the ground is 80 degrees. What is the length of the ladder? All right. This is a wall, right? This is the ground level, and we have our ladder right here. So what are we looking for? We are looking for the length of the ladder. Let me call it x. The angle between the ground and the ladder is 80 degrees. It is given. The base of the ladder, this is the base of the ladder right here, to the wall is 4 feet. So this is 4 feet. So you can see that we have the adjacent side, we have the hypotenuse. We are going to use cosine. So cosine of 80 degrees is equal to 4 divided by x. And therefore, x will be equal to 4 divided by cosine of 80 degrees. And this is approximately 23 feet to the nearest whole number. Now let us move on to question number 4. Question number 4, we are given a rectangle right here. You can see the side lines, and we asked to find this angle right here. So one thing you should know is that the opposite sides of a rectangle are equal. So this is 5 centimeters, and this is 12 centimeters. So this is the opposite side, and this is the adjacent side. We are going to use tan ratio. So tangent of x is equal to opposite divided by the adjacent, and x will be equal to tan inverse of 5 divided by 12, and this is approximately 22.62 degrees. X is approximately equal to 22.62 degrees. This is in 2 decimal places. Question number 5. We are given a right angle triangle right here. We are asked to find the length of AC, the length of AB, the perimeter of the triangle, the area of triangle. All right. So let's begin with A, which we are looking for the side length AC. This is AC, which is the adjacent to that angle 70 degrees. So therefore, since we have the opposite side, we are going to use tan ratio. So tangent of 70 degrees is equal to opposite divided by the adjacent, which is AC. Therefore, AC is equal to 12 divided by tangent of 70 degrees. And this is approximately 4.37 centimeters. AC is equal to 4.37 centimeters. We are done with this side. Then we are asked to find this side as well. So since we have two sides, we can apply Pythagoras rule, or you can use sine ratio, because the relationship between the hypotenuse, which we are looking for, and the opposite side is sine. So it will be sine of 70 degrees to be equal to 12 divided by the hypotenuse, then make hypotenuse the subject. So this is the B part. Sine of 70 degrees is equal to opposite divided by the hypotenuse, which is AB. Therefore, AB will be equal to 12 divided by sine of 70 degrees. And this is approximately equal to 12.77 centimeters. But if you like, I told you, you can say that the hypotenuse squared, which is AC squared, equal to the opposite squared, which is 12 squared, then plus the adjacent side, which we have obtained earlier, which is 4.37, also squared. Then AC will be equal to the square root of the whole of this. Once you simplify that, you have the value of AC. All right, let us move on to the next question, which is C. Find the perimeter. Perimeter is the total length around a figure. So we are looking for the perimeter. It will be AB plus BC plus AC, right? Around. So AB is what? 12.77 plus BC is already there, which is 12. Then lastly, AC, which is 4.37. So let's add all of this together. All together, we have 29.14 cm. So this is the perimeter. And lastly, we are asked to find the area. So the area, remember, of a triangle is base times the height divided by 2. The base is what? AC, and AC is 4.37. So we have 4.37 multiplied by the height. The height is 12. Then divide by 2. You can plug everything into the calculator. This is 26.22 centimeter squared. So this is the area. Question number 6. A helicopter leaves a point A and flies 40 miles due east. Then the helicopter flies 10 miles due south and arrives B. So it starts at A and stops at B. Work out the bearing of B from A. All right. So let's assume this is point A. It moves to the east direction, which is 40 miles. Then it takes a turn 10 miles south. This is south, which is 10, and arrives at B. So now let us connect A and B together, something like this. So we are looking for the bearing of B from A. To find the bearing of B from A, we need to find this angle and also this angle right here, which we know is 90 degrees. Because to find the bearing, you have to start from the north of A down to the line heading to B. The total angle here is what we are looking for. So let's start with this interior angle. Whatever we obtain, we add it to 90 degrees. So let's call this theta. You can see that this 10 is directly opposite to the theta, and we have the adjacent side. So therefore, tangent of theta is equal to what? Opposite divided by the adjacent side, which is 40. And theta will be equal to tan inverse of 10 divided by 40. Therefore, theta is equal to what? 14.04 degrees in 2 decimal places. Then we conclude, because we are looking for the bearing of B from A is equal to 90 degrees plus 14.04, and this is equal to 104.04 degrees. As simple as that. Now let us move on to question number 7. A boat leaves a port and sails 55 kilometers due west and then 30 kilometers due north and arrives an oil rig. What is the bearing of the oil rig from the port? Let's assume this point right here is P, that is the port. It sails what? 55 kilometers due west. So this is the west direction, 55 kilometers. Then it sails again 30 kilometers due north. We're talking about this direction. This is 30 kilometers. Then it arrives what? Oil rig. Let me call it R. So let me connect these 2 points together. So what is the question? The question asks us to find the bearing of the oil rig from the port. So this is the oil rig, right? So we want to find the bearing from the port. So let me shift this one a little bit. To find the bearing, let us draw a cardinal point here. This is our cardinal point. We need to find the total angle from this point down to this line heading to R. So the total angle there is what we are looking for. So we already know that this is 180 degrees, a straight line. This is 90 degrees. We need to find this one. Let's call it theta. What is the relationship between these two sides and theta? Is tangent, right? So tangent of theta is equal to 30 divided by 55. And therefore theta will be tan inverse of 30 divided by 55. And this is approximately equal to 28.61 degrees. So to find the bearing, therefore the bearing of oil rig from the port is equal to that 28 degrees plus 180 degrees plus 90 degrees. Let's add all of them together. Altogether we have 298.61. So this is equal to 298.61 degrees. This is the solution. All right, the last question reads, shown is an isosceles triangle. We are asked to calculate its area. This is one of the applications of these trigonometric ratios. To find the area of a triangle, we need the base times the height divided by 2. But we have the base, we don't have the height, so let's find the height. This is the height, right? Let me call it h. And the height will divide the base into 2. So this will be 5, this will be 5. So let's concentrate on this one right angle triangle. According to Pythagorean theorem, the hypotenuse squared is equal to the sum of the squares of the other two legs, 5 squared plus h squared. Therefore, h squared will be equal to 12 squared minus 5 squared. This is equal to 144 minus 25, and this is equal to 119. So h itself will be equal to the square root of 119, which is equal to approximately 10.9 centimeters. So we have the height. Already we have the base, so let us multiply and divide by 2. And therefore the area will be the base, which is 10, multiplied by the height, which is 10.9 divided by 2. And A is equal to 54.5 cm squared. And this is the end of this tutorial. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.